Powerful, tough, reliable, proven performers. John Deere batteries, built to supply dependable power every time, start after start, day after day, year after year. John Deere batteries are built to be the best. Manufactured to John Deere's exacting original equipment specifications, experts agree that the John Deere family of batteries beats the competition cold. In fact, the John Deere battery supplier is the world's largest battery manufacturer, and John Deere batteries are the highest grade they build. It's all in the construction. In this program, you'll see the superior engineering and rugged construction that goes into every John Deere battery. Following that, Howard will walk us through just how the John Deere battery compares to its competitors, feature by feature. Let's take a look.
The grid is the heart of the battery system, and it's extremely important that the most attention to detail and design is brought into the grid. The John Deere grids are a full cast grid, meaning a full side frame, bottom frame, and tapered top frame. All of this is designed by computer to optimize the current path, which is important when you go to turn the key. We term this a computer design radial grid design, and as the name implies, all of the wires radiate to the lug, which is important when you go to turn the key to start your engine. The John Deere grid design is heavy cast wires, which reduces resistance and ensures long battery life. If we compare that grid technology against some competitors, we find that they utilize an expanded metal negative grid, which is much lighter in weight and in design, does not incorporate side frames. It's much lighter and flexible, much smaller bottom frame, and no tapered frame along the top. The wires have a zigzag pattern as opposed to being directly towards the lug, which is important for reducing grid resistance and improving startability. Some manufacturers utilize a cast grid that is very light, quite fragile, and flimsy. As you can see, these wires do not radiate towards the lug. They're done for the lightest weight grid design and the least amount of material that they can use to get away with this particular type grid design.
Specially designed heavyweight grids are only the beginning. John Deere's battery assembly is designed to provide cold cranking amperage and reserve capacity that is optimum for machine performance.
The grid is the heart of the battery system, and the heart of the plate that makes it all operate is the paste that we put onto the grid. The paste that we use in the John Deere strongbox batteries is a high-density paste, which means it's designed for rugged durability, vibration, and cycle life, giving us the highest cold cranking power and reserve capacity that we can possibly get. The paste is important because that is where the electrical energy is stored, and the grid is used to remove that energy from the battery. When we talk about the way that the paste is adhered to the grid, and we compare that against our competitive batteries, we have, again with the expanded metal grid, and that being pasted, we have a grid design here which, comparably speaking, does not hold the active material in place as well as the John Deere plate design. Consequently, you do not get the energy out of the battery that the paste is intended to provide, and the material sheds from the grid and falls to the bottom of the cell, or in worst case conditions can present a short between the plates within the battery. Mechanically it's not as strong, and the vibration will shed this material from the grid and reduce the cranking power and the reserve capacity power within the battery over the life of that battery. The difference between the radial expanded computer design grid that John Deere used and the expanded metal grid is that the paste is totally encapsulated in the radial design grid that we have here. When you use expanded metal grid technology, chunks of the paste material can fall out of the plate, and this will float around the battery cell and can possibly short out the cell and lead to a premature failure. Going back to our John Deere grid and plate design, we then insert the plate in a tough polyethylene separator material, microporous plastic, which ensures long life and is a very, very rugged separator. The lug is all that is exposed at this point, and we then stack positives and negative plates adjacent to each other, and we cast them on with a very heavy duty top lead strap. Now this bar is made out of lead and is the conductive current path, or the bus bar, which collects the current from each of the grids into one bus bar. That's what this appears when it's in the cast on state. We then take the plates and we set them down in the cell, and we have an epoxy anchoring material, two-part epoxy resin and hardener in the bottom of the cell, which the element is potted into. At that point, when this dries, it is an integral part of the battery container and the cover and gives us a rugged battery design. We then take this bus bar and what we term the tombstone up in this part, and we weld through the partition with a 1/2 inch diameter. This accumulates our voltage from cell to cell for the 6 cells we have in the battery and gives us a 12-volt John Deere strongbox battery.
One look inside a John Deere battery, and it's easy to see they're built to take the pounding handed out by heavy off-road machinery. But even the exterior case design contributes to the superiority of the John Deere battery.
The exterior features of the John Deere strongbox battery include a one-piece solid molded polypropylene battery container with heavy vertical rib pattern designed into it for extra mechanical strength, heavy molded walls, which are much thicker than anything in the automotive industry. The bottom of the battery container is a flat design which allows the battery elements to be placed all the way at the bottom of the cell, allows for maximum acid volume above the plates. This provides for longer battery life and reduced maintenance. We also have a flame treating that we provide in the bottom of the battery cell, which allows the epoxy and the plates to be solidly bonded together. Moving to the top of the battery, we have a one-piece molded polypropylene cover. We have a vent system incorporated in it, which we call a manifold vent system. And this vent system collects all of the gases from all of the cells and vents them out of one convenient port where you can drain away any excess fumes or fluids. We also have vents which are accessible so that the individual can get into the battery and observe the electrolyte level and make sure that we have the proper fluid levels in the battery over the life of the battery.
Heavy-duty radial grids for superior conductivity. Tough polyethylene separators for better insulation. Rock-solid epoxy anchoring of plates for longer battery life. Extra heavy intercell connectors for more efficient power transfer. And thicker through the partition wells to handle higher electrical loads.
What we have is an expanded metal negative grid design, which is lighter weight, and again, it's automotive technology that we really do not want in our off-road batteries. The bottom of the element is not epoxy anchored. Many other construction features that we have in the Napa battery are a bit different. We have a brickwork pattern on the outside of the battery, which is a little bit different design than the heavier vertical rib pattern that we have in the John Deere strongbox battery. The one-piece cover design that they have here is similar, except they have a removable vent design compared to the single pod vent, the single threaded vent design that we have on the John Deere battery. Some of the other construction features inside the battery are just not built for the heavy-duty off-road market as the John Deere strongbox is.
When you look at the features, Deere is the clear winner. When it comes to tough, reliable features, there's no comparison. And it doesn't stop there. With other brands, acid is added at the factory, making that the battery's first day of life. Batteries are perishable. By the time it's purchased, it may have been sitting on a shelf for several months, losing 10 to 80% of its cold cranking amperage. John Deere batteries are designed for a wide variety of applications, from garden tractors and lawnmowers to giant tractors and combines. For all brands of autos, pickups, and light utility vehicles, John Deere batteries get the job done.